Okay, great. Well, thank you for the roll call and thank you for the invitation to give a briefing on this. I'm happy to see many people on the call that I recognize and have met in the past, and then also new people that I'm just meeting for the first time. So I'm glad that we've gathered here today to talk a little bit about the IPCC Special Report on Oceans and Cryosphere in a Changing Climate. That's the acronym SROCC. And I mean, first of all, I want to thank people on this call that were contributing authors to this text. And also I recognize people that have provided expert review comments. And all of that input really made the report be what it is. And so what I was hoping to do today was to look at this special report, which is very broad, focusing on the entire oceans and cryosphere, to focus in a little bit on the perspective of permafrost, since this is the permafrost action team with IARPC, and then really to consider, what is in the report and how we can use this as a community. So I'm going to give you some details about what happened to permafrost, but I'm also going to be pointing you back to actually look and read the report for yourself, because I'm going to give you a sort of a digest version, but really open it up to a discussion that's asking the question of, now that we've assembled this material, how does this influence society and policy, which is the goal of the IPCC. So I'm going to start off, Christina gave sort of my introductions. I'm going to go and tell you just a little bit about the IPCC process, and then we'll look at the permafrost parts of this report. So can you guys read the text? Maybe Christina, is that big enough that you can see some of this? I don't expect that we have to read every word here, but the first section just tells you that this special report was released in the last week of September. There was a approval process of the summary for policymakers that took place in Monaco. I'm going to tell you a little bit about that approval process, but that approval process built on a 2-year time frame of producing this special report. So it started out in 2017, concluded in 2019. That approval process started out at the very beginning with a scoping meeting of the topics of the report. That also took place in Monaco, as did the approval. There were 4 author meetings, 2 author meetings that were focused on the summary for policymakers, this high-level introduction, and then this final approval plenary that this slide describes that took place in Monaco along with a press release. That also includes, I would say, countless emails, teleconferences, Slack messages, and lots of frayed nerves in the production of this report. But it's over, it's out, and so that's the focus of this presentation. Maybe just to point out, the bottom here says that this report, the SROCC, the Special Report on Oceans and Cryosphere, is one of 3 special reports, including the 1.5 degree report that was released last October, and then the land report, SRCCL. And this collection of 3 reports is important because they are finished within the scope of the assessment report 5th cycle and the 6th cycle, which is coming up. But these 3 special reports are going to be used to inform the next conference of parties that's happening in December in Santiago, Chile. And I'll come back to that at the end of that. But it's sort of an important time in terms of the IPCC synthesis science effort. Okay, so let me just give you a few of the details of the whole report. So again, this is thinking much more broadly than just permafrost. There are over 100 scientists acting as chapter authors, lead authors, and review editors. They're selected through a nomination process by the IPCC from countries around the world, trying to get a real representation of scientific expertise. Of course, the scientists that are listed as authors are not acting alone. They're trying to synthesize information provided by people in the community, including people on this call. So it's the responsibility of the authors to be looking at the literature, communicating with the community, and trying to assemble topics of interest. As it mentions, there's almost 7,000 publications that are actually cited, but one thing to note about IPCC, it's not a review, and so probably of the 7,000 papers that are cited, I would say, based on my section, I probably read 10 other papers and considered 10 other papers for every paper I cited. So you might multiply that, and maybe that's someone can fact check me if that's really 70,000 papers, but it felt like it when we were writing the report. And then you can see the last thing, we received over 30,000 comments that we responded to, each one in tracked in Excel sheets about the changes that were made. Based on all this, I should say at the initial scoping meeting, there's a page limit, a topic, topics that were set out by the scoping meeting. So not everything was included, and it was a real challenge and negotiation to get important topics represented when there were so few words available. So that's just a little bit of a background. This approval process just happened at the end of September in Monaco, like I mentioned. I spent 4 days in this windowless room in the basement of the Grimaldi Forum in Monaco. It was preceded by a 3-day author meeting that took place right before it. The 4 days looked a little bit like this. I couldn't tell if it was day or night. Every morning they would show us this schedule. So you can see this is actually near the beginning of the report. So it's day 1 through day 4. It was divided into these 3-hour sections because everything was translated into 6 different languages. So you were listening to the proceedings through your headpiece. There was every country of the UN potentially represented. I think there were delegates from over 100 nations present at this approval. Maybe I'll point out a couple things of the schedule. You can see on day 1, there's a crossed out evening session that got crossed out due to sort of procedural disagreements. They helpfully added in on day 4 a 2400 to 3 a.m. slot to account for that. And you can see most days scheduled through midnight to go through this. And this approval process is a line-by-line comment on everything in the summary for policymakers and really a consensus vote on whether every word was approved by these 110 nations. The only thing I'll note on the slide also is look at day 4, the 23rd, and it's scheduled to end at 23:30, so right before midnight on day 4. And I'm just highlighting that because I'll come back to it in 2 more slides. And then you can see that within the SPM, the summary for policymakers, there are all the different sections that I'll kind of point out to you during this talk. So they would show us this slide at the beginning of the day and update it. Then they would also show us this slide. This slide showed you the number of words that were approved and the amount of time that we had used up. So this actually, you can see, was kind of later in the process. Maybe we're in day 4. So that blue bar it says 93% used of our interpreter hours, and at that point we had only approved 51% of the words. And so, as was often the case, the amount of words approved was far behind the time that we had. Each nation had to comment on each section, or had the ability to comment, and then the authors and the scientists would decide whether the changes that were suggested could be implemented and still be consistent with the science. So it was a real consensus operation to produce. Again, this is the summary for policymakers section of this report. Okay, it was approved. You can see at the top it says the final approval occurred not in the 4-day period, but instead on day 5. So it did not end at midnight as planned, but it kept going the whole night long until 11 a.m. to try to get all countries on board. That top picture shows you yachts in the Monaco harbor that were amassing there, because the next thing after this IPCC report was a yacht show that was happening, and the yachts were all waiting to come into the harbor as the sun was rising. And then the picture below shows scientists, and the people in the middle are the co-chairs that were leading this process and facilitating the dialogue between scientists and the policy folks that are trying to co-produce this document. Anyway, I thought I'd give you that little background so you can understand how the words in a report like this start off as representative of the science community, but I would say they involve also the policymaker community by the time that summary for policymaker is completed and approved. So I wanted to I wanted to stop on this slide for a second and open it up a little bit. What I wanted to do with the time that I have in this presentation is trying to understand this large document that synthesizes all this science. What I want to think about with this group is ask, how do you as an individual understand what was written in this report? So where do you go and look both in the summary for Policymaker and in the main report? So that's what I'm planning to cover on the next several slides. But I think that second question is also what I want to think about, which is, how do we as a group of permafrost scientists or cryospheric scientists and managers take this information that's now compiled as a special report and put it to our best use? So even though it's finished and published, I consider this as the first jumping off spot as how we can bring this information to people thinking about policy. So these two questions I'm sort of planning on addressing already, but I want to break for a minute and ask if people have any other questions they want to hear me talk about in the next bit. So I'm going to mute myself, and I know it's a little hard with so many people tuned in, but I'm going to just leave sort of an open space. And if you have a question that you don't think fits into either of these, please speak up, and I'd like to hear what you want to know about this report. So I'm pausing now.
Ted, this is Julie Brigham-Grady. I'm hoping that you might address in your talk today how the findings, particularly about abrupt deep thaw and emissions, are potentially going to influence the national agreed upon emissions from the different countries if they account for it. If they don't, it seems to me like they may have to account, they're going to have to lower their emissions even more to compensate for permafrost. So I'm hoping you'll address that today.
Great, thanks for that. And yes, we'll touch on that topic of where it's at. How about that? Other questions or comments? You can hear me now, right? Thanks for that feedback, Julie. And that topic will come up, but I think we'll dive into a little bit of the details. And then again, I think what I'm going to try to do is give you an overview of what's in there, and then we'll return back to that kind of specific question that Julie asked, and also potentially other specific questions that other people have as well. The first thing I wanted to kind of tell you is that in this short briefing, I can't read through all parts of the science to you, but I want to show you a little bit of how you can find out more than maybe what you've heard in the news. So the first place I'm just going to start is that whole approval process that I just described was the approval for this summary for Policymaker. That was what was agreed on line by line, but you can access this approved report and all of the science chapters at the IPCC SROCC homepage. And so that's a first important waypoint, is you can go download these materials, and I encourage you to do that. That's the first part towards figuring out what's in the report and what's not. This is just giving you an outline of what's in there. So the whole report consists of 6 chapters. So you can see it's much more broad than Arctic permafrost. It's really covering many topics here. Let me see if this is going to work. I was a lead author on this polar regions, and for IARCUS, that's kind of where we're focused in on. That's just one of these 6 chapters, but I would also encourage you to look more broadly across the report as a whole. If we dive into what's in the polar regions chapter, this kind of describes topics in particular. Again, they're focused on many things. I'm highlighting where the word permafrost shows up in just one of these bullet points, but these were elements out of the scoping document. So you can see this bullet point: changing snow, ice, thawing permafrost, thinking about carbon flux and climate feedbacks, impacts on infrastructure and ecosystems, and community-based adaptation. The point of showing you this is that even with the scoping document, it was putting out what governments wanted to hear about. So it was not every topic permafrost, but it was a subset of them that influenced policy. Probably the other important thing to know about these special reports is it combines science from Working Group 1, the part of IPCC that's thinking about the physical basis of climate change, but also the impacts and responses of people, which is Working Group 2. So these are both encompassed in this one report. It's a little bit different than how the assessment reports are structured. Working Group 3, which is the mitigation part of IPCC, was not part of this special report. So this is how you drill down and figure out what's in the permafrost part of the polar chapter. I'm using this graphic, which is modified from something that shows up in the report, but it's really thinking about permafrost from the lens of its impacts on people and ecosystems, and in particular, ecosystem services, what people are deriving from ecosystems. And so we know the definition of permafrost by itself focuses on temperature, this perennially frozen ground. But if we think about the lens of people, we're thinking also about these global implications, which have to do with carbon feedbacks to the climate cycle. And then we're also thinking about local impacts. Primarily, these are happening through ice in permafrost ground. So we're thinking about impacts on ecosystems, disturbances, vegetation and wildlife, as well as infrastructure and the way people access the landscape. So we're really considering sort of this 3-part system for permafrost from this lens of what people rely on permafrost for. So that's kind of a guiding principle to how the report was written and the topics that we covered. What I want to show you now is not all of the bullet points, but it's again kind of focusing you in on how this information is reported. So in the summary for policymakers, it's drawing upon material from the chapter. And the summary for the policymakers was split up into 3 sections. There were observations, and I'm showing you an example of an observation bullet point here. There's projections, which I'll show you some examples, both local and global. And then there's responses by people. And so those 3 sections are made up the summary for policymakers, and we try to fit in permafrost topics into those. This particular bullet point is just one. It's an example of permafrost focused one. So it's reporting on observations like people like Vladimir and the entire global terrestrial network on permafrost have reported, but changes in permafrost temperature are well documented. It has a statement on the amount of carbon stored in permafrost region soils, and then a last statement about whether there's detectability of carbon releases currently, both methane and carbon dioxide. The last sentence, permafrost thaw and glacier retreat have decreased stability of high mountain slopes, reminds me that most of these bullet points merge material across several chapters. And so in this case, it's merging material from the polar chapter where I was an author plus the mountain chapter. So almost all of the summary for policymaker bullets are kind of merged topics across these themes. So the other thing to highlight in these summaries is that this whole report is an assessment, meaning we didn't review, not every paper that's read is put into here, and what's put into here are the key papers, and then the chapter authors plus the feedback are trying to give confidence statements of how well a topic is understood. And so this relates a little bit to what Julie asked the question about of whether we can put information directly from the science into the policy. And I would say that the policy people are looking for statements that are at high confidence or very high confidence. They are more nervous about medium confidence, and even low confidence statements were ones that we often considered not putting into bullet points. But the key thing to think about here is that we put in what we thought were important processes, and we tried to assess the level of science. So one guide to this is, if you look at the confidence statements, it doesn't mean that we don't think that it's an important process, but it's telling you a little bit about the scientific documentation. Now, to get beyond the bullet points, of course, you have to read what's here, and then if you look at the very last line, it's telling you where in the main chapters the information is detailed along with the citation. So in this particular bullet point, we have material from chapter 2, that's the 2.2.4, 2.3.2, and then also chapter 3, 3.4.1, 3.4.3. So these bullet points are a guide to where in the chapter you can look at the science. Okay, so that was just a little bit of a kind of overview, but I think what I want to focus on in this talk, you'll sort of see in the permafrost world what things we know a lot about. So we gave very high confidence to a documented trend of permafrost temperature increasing across the permafrost regions writ large. And again, this is GTMP, Vladimir Romanovsky's, others on this call that have contributed to this information. On the carbon side, we have lower confidence, in part because we have good information for surface pools, but we still are limited in our information about deep carbon, where we know it exists. We've quantified it in some places, but compared to the entire Arctic region, we're still data poor. And then perhaps I'll point out, mostly importantly, the third sentence says there's medium evidence with low agreement whether northern permafrost regions are currently releasing additional methane and CO2 due to thaw. So what that's telling you is that we've done a lot of science on this exact question. Is the Arctic currently releasing net methane and CO2 to the atmosphere, this feedback to climate? And we really have a lot of conflicting data on this. And each study, I would say, in by itself is a good study, but studies do not all line up of whether this feedback is already occurring. And I would in part chalk that up not to that the science has been low quality or there hasn't been enough of it, but it's a remote understudied region that's still limiting us. So I would say that's an important finding, even though we're at, I would say, low agreement whether this is already occurring. Okay, so I'm gonna move on from this bullet point to, so again, this is observations. I'm gonna give you, I'm not gonna show too much here, but you can dive into the chapter. This is a figure out of the main text. It's adapted from data that's already been published. So I've circled this data that is from the GTMP showing temperature rise in permafrost. You can see that there's other elements here, snow cover, river discharge, as well as permafrost. But this figure is showing you both the observations on the left-hand side and then the projections out of the CMIP archive on the right-hand side. So we have well-documented temperatures going up. We have projections from the global models of decreasing permafrost area under all emission scenarios of the future. But importantly, if you follow something like RCP 2.6, if you mitigate total carbon emissions, you save a lot of permafrost. Okay, so you can look back in the chapter and find out sort of the details of that and a lot of the numbers that go into such a summary bullet point, but I just wanted to point out this figure that's there. So let me advance and go to sort of a second section of the summary for policymakers. Now we're in the B section. So I skipped over many bullet points that had to do with oceans and other aspects of the cryosphere, just again focusing on permafrost. This one probably touches on what Julie asked, which is what do we think is going to happen to permafrost and carbon in these future scenarios? And so again, this relates directly to that figure I just showed, where we're expecting widespread permafrost thaw under all scenarios. If you take the CMIP models, they say that RCP 2.6, which is keeping the world below 2 degrees warming, we're likely to lose a quarter of near surface permafrost area. If we follow 8.5, we're talking about 70% as a mean for that disappearance of permafrost. So if you lose all this permafrost, you warm the ground, you thaw the organic carbon that's there, that potentially leads to the release of tens to hundreds of billions of tons of permafrost carbon as CO2 and methane by 2100. And then that's given a medium confidence. And I'll point out maybe to Julian, I'll show a slide next from the main text, but we still have this range of 10 to hundreds of billions of tons of permafrost. And partly that depends on what kind of knowledge system we're using to evaluate it. And that it also depends on what processes are included in those estimates. So we know for sure that if we follow lower emission scenarios, we kind of dampen the response of things. So mitigation at the global scale is going to help save permafrost and probably reduce emissions. We know also that a lot of the global models are tracking total carbon. They don't always break down methane, but we know that methane by mass is a small fraction of it, but it has this higher global warming potential. So again, it's going to be a major contributor to the climate feedback. And then the last sentence says that we expect that plant growth, which is taking up carbon dioxide from the atmosphere, also stimulated by warmer conditions, is projected to offset some of these releases by growing more biomass, inputting more carbon into the soil, but we don't think that these plant offsets will match carbon releases over the long term. Again, you can see the breakdown of confidence statements, and you know, one issue, Julie, with putting this right into policy is that we need the science to push us up into kind of high confidence or very high confidence in order to tell policymakers exactly what to do. That's one line of thinking. The other line of thinking is saying, okay, we have a range of estimates, and if we take a risk approach, a risk framework to this, we might think about what are possible high-end emission scenarios, and we could ask policymakers to adopt a risk framework when thinking about this. The risk framework meaning we don't have to wait necessarily for science to reduce the uncertainty all the way, but we can look at the high end and say, well, if those are possible estimates, we don't want to go there, and what would we do to avoid those worst case scenarios? So that's kind of something to be thinking about also. I'm not going to go into the details of this, but this is again the figure from the chapter. So it's a new, it's an assessment essentially of all of the emission estimates publications that are out there right now. It's divided, there's a zero line at the top that's essentially pointing, everything below there is saying here's net carbon emissions to the atmosphere from the permafrost region. So most of the bars are below there. There are bars on the top which show net carbon moving into the terrestrial biosphere. So there are some models in the recent period that have said by 2100, that's the time frame of this figure, we might have more carbon moving into the Arctic. And so one important take-home point is we've done a lot of new science on this question, but we've actually widened the range of estimates. Now, part of that widening has to do with the kinds of processes that are considered. I would say in this graph on the right-hand side, there's more of a focus on what plant response could be, whereas on the left-hand side, we started out thinking about what could come out of the permafrost soil. So there's a little bit of an apples and oranges across here, but I would say it's probably true that we haven't merged that widened our uncertainty range as a result of new science. You can read about the details there in the papers that are cited in the chapter itself. So that's a lot of focus on carbon. I want to just highlight a couple more things before I sort of open it up for discussion. Again, I can't go through all the topics in the report right now, but I want to just highlight that there's a third section of the summary for policymakers. So there was observations, there were projections, and there were responses. What we know about the permafrost is that we have a general response of people being mitigation of carbon emissions. But I think it's also important to think about what kind of other response options there are. So this one that I took out was focused a lot on, it mentions ocean and cryosphere. Sorry, I just went forward. in the first sentence, but in the middle of it, it says, sustain long-term monitoring, sharing of data, information and knowledge, and improved context-specific forecasts, including early warning systems. Now it mentions predicting ocean things like El Nino, La Nina, tropical cyclones, and marine heat waves, but I think this community should think about, do we have an early warning system? Do we have an appropriate warning system to tell us if emissions of methane and CO2 are happening, and are they changing now? So that's something just to put in the back of your mind, because I would argue, again, sort of our detectability of Arctic carbon emissions now is lagging a little bit further behind, I would say, than something like these forecasts that we've been putting out for future vulnerability. Anyway, I bring this up in the context of this third section, this response options. So this was thinking, I brought those examples about the carbon climate feedback. I want to highlight, of course, there's many people on this call and there's other topics in there. Again, you're going to have to kind of read into the details, but I'm going to show you a couple of slides about these local to regional impacts. And so in the report, again, this is thinking about projections, but this is an idea of thawing permafrost impacting infrastructure. And so thinking about the built infrastructure that's there, some medium confidence statements there. We have a figure adapted from April's paper. April, who's on the call, looked at damages that happened with different emission scenarios. That's the red and the blue here, and then to different parts of infrastructure. This was a regional study in the state of Alaska. It also looked at the potential adaptation measures that engineering could provide to harden the infrastructure, and the kind of cost savings that would result of that. So that is summarized in the report and in this figure, and also you can go back and read the original publications on that. So along with human infrastructure, there's also both observations and projections on how thawing permafrost impacts ecosystems. Now I'm showing you, 4 bullet points, because 2 are in the observations, 2 are in the projections. I'm not going to read through these, but if you just look at that bottom statement, it's looking at things like the fire regime, about abrupt thaw that Julie asked about, thermokarst and lake changes, impacts on species, vegetation, hydrology, wildlife that people depend on. So there are bullets on all of those topics. And then also, moving on to the next one, there's thinking about how ecosystem responses of thawing permafrost then impact people. So how do people use the landscape for subsistence, and how are they impacted by permafrost thaw? How is their transportation, their access to the land? How's the infrastructure? And then importantly, what are the governance options that exist in order to deal with these changing conditions? So I know I'm sort of skimming over a lot of topics, but the main point of this is not for me to tell you about them, but to have you go read the report. So my last slide before opening up to discussion is just coming back to those 2 questions that I showed you earlier. I think I told you about how to find and use the assessment messages in the report itself. I think I'd love to hear from you guys about, we have this information that's summarized for policymakers. I will say that there was a press release on Wednesday, 25th, that introduced the entire SROCC to the world. It happened to be the morning after Nancy Pelosi announced a formal impeachment inquiry. So I would say that some of it made the news. I would say permafrost didn't make it too high up, but these reports contain a bunch of information, and I think it's up to our community to communicate that. I've listed a couple of things below. You guys are at the IARPC briefing, which is the first thing on this list, but the next couple of things are things that I'm involved with. One being the COP meeting in Santiago, Chile, where there will be a side event called the Cryosphere Pavilion and a Permafrost Day. And the important thing about this COP event is that this is the first time that nations are reconsidering their NDCs, their nationally determined contributions, their mitigation efforts. And just like Julie asked the question, if Arctic emissions are going to be considered in that, we have to get the word out on what's in this report. And then finally, Christina mentioned our Permafrost Carbon Network workshop that's happening the day before AGU. which everybody on this call would be invited to register for. So I'm going to leave it at that. There's a bunch of information packed into that, but I would like to hear, you know, how yourselves, this community, could focus on that second question. How can you use this material and carry this information forward? And with that, maybe I will turn it back to Christina to moderate or open it to discussion as a whole. Thanks.
Thank you. That was really great. If you want to ask a question, unmute yourself. Otherwise, if you're uncomfortable doing that, maybe you could just ask your question in the chat box and either Meredith or I will read it out. That might make it also easier. I actually have a question to start out with, Ted. What I found, not surprising maybe, but it was kind of obvious that there's a lot of medium confidence, sometimes even low confidence. There's very little high confidence when it comes to permafrost. And I wonder how much that might influence communication of the results. Like, how easy is it to communicate? We have low confidence or medium confidence, and if you have any suggestions for that.
Yeah, so that's a great question. And confidence, so confidence is how well we know a particular statement. And I think what was hard with the report as a whole is how do we assess confidence across these very different spheres of knowledge, all the way from observed impacts to projected impacts to responses of people. What I would say is for permafrost, is narrowing it in, I think it says a lot about what we know about the problem, where you know, the permafrost community and the definition of permafrost has led us towards documenting temperature quite well. But going back to some of those other spheres, I would say our knowledge of the carbon pools and their potential emissions is more limited, and that's why you see that. And then thinking about where that ice is distributed exactly, both regionally and globally, is even probably lagging behind carbon. And those are important issues, thinking about how permafrost impacts people. So I would think of two things, which is every bullet point that shows up is a really important topic. So even if it has a medium confidence, doesn't mean that the topic's not critically important. It's just that we don't have as much data as we'd like to, kind of relative to some of the other components. So that's the way I would look at both the topics that are covered and the assessment levels.
Okay, thank you. Questions from the audience?
Hi, Ted. It's Peter Griffith. How are you? You don't have to unmute to say that. You're great. One thing, I've been poking around on the website, and I found lots of the PDFs, but I have not found the figures in a PowerPoint type format to be able to pull out and use. So if anyone knows where the figures are, maybe they could put the URL in the chat box. Two things about some of the uncertainties levels. One of the things that did pop out was that there seemed to be a high level of certainty that lower emissions scenarios would result in less permafrost thaw, which seems to me that well, you know, you did highlight it in the. I was hope that would be something that would be clear enough to policymakers that there is confidence that we'll get less permafrost thaw in the lower emissions scenarios. And then I have a part two if you want to reflect on what the discussions have been on that first.
Yeah, Peter, I think that's a good point, and I don't think I'll go back through the slides, but if you looked at the projections bullet points we give, again, now I can't remember if it's very high confidence or high confidence to that projections of permafrost temperature in the fact that you can save permafrost by mitigation. So if you keep warming below 2 degrees, you save a lot more permafrost than if you do nothing. And so that's either a high confidence or very high confidence statement. So hopefully that's reflected. I'll say one other thing about the the confidence statements where temperature, so if we think about permafrost temperature and we think about warming climate, it's a little bit easier to say, okay, warming climate, through physics, we think that the ground will warm at some rate lagged by its insulative property. But with carbon, you have carbon going in and out of the system. So you have a sort of offsets to the releases. So that's one reason why the confidence could be higher sort of on permafrost temperature versus the carbon cycle.
Right. And the part two is in some of the areas, for instance, carbon emissions from permafrost stocks of carbon, which are known to be somewhere between large and very large. I think, is there a way to say that there's confidence that there isn't a small amount of carbon stored in the permafrost? And therefore, the uncertainties in how much carbon would be released are not, should not assure policymakers, but instead should trouble policymakers.
Yeah, Peter, that's a great comment. And if you look into the chapter, we sort of do a little bit more nuanced statement saying, we know of all this carbon at the surface, and the deeper we go, kind of the less data we have. But there's two important things that show up in the report. One of them is a box in chapter 1. I didn't talk much about it, but it's a concept called deep uncertainty, which there's a little information about permafrost itself, and it's describing the same problem that as we've worked on it more, we get a wider range of possible answers. But there's a whole framework of thinking, which is there's two ways to approach this. One is, okay, scientists need to reduce uncertainty until it's really small, and then policymakers can do something. But in the meantime, they can't do anything. And that has been a track that climate science has been kind of stuck in. The other option is saying we can use a risk framework, which is saying we know that there are these high-end estimates. They haven't gone away after a lot of study. There are these worst-case scenarios. Maybe we should design some of our policies focused on avoiding these worst-case scenarios,
Right.
Even if we haven't reduced sort of the whole distribution. And I think that that's sort of a message, and maybe I'm hearing that in your language, that we need to push forward. Even if we have a distribution like this, we still have these worst case scenarios that have not gone away and have been supported by all this new study. So I don't know if that kind of language helps your thinking.
Yes, that's very helpful. Thank you.
I think this may actually also answer Julie's question that she put into the chat box, which is it's important for COP25 that science makes it clear what it will take to keep the world below 1.5 degrees versus 2 degrees. The public will think this is trivial, but the response of the permafrost might be huge. How do we make this clear to negotiators at COP25? So it seems like this is very similar to what you just answered, Ted. Can you see the question in the chat box?
Sorry, I've lost the chat box. But I think what you said is really important. I think combining kind of what Peter said, and I guess for Julie, the question I would say for permafrost, whether there is some science about permafrost at 1.5 degrees, and that's largely not found in this report, but it's found in the 1.5 degree report. I would say that's even less solid than all of this other stuff that we had out of 2 degree warming. But I think, I mean, that's an important question you raise, is like how much of our job is to highlight this 1.5 to 2. I would say that this report does more to look at 2 degree warming versus doing very little, which is the RCP 8.5. But I think your point is well taken. When people are getting together in Chile, they're going to be combining these 3 special reports to really highlight those things. And so I think that low end is really important. And I think the point is we need to have action even in the face of this kind of deep uncertainty. I think maybe that's a message to policymakers. We can't wait to figure out more.
Yeah, that's actually my point. And I just worry about these small numbers not having a big enough impact. But that's for the negotiators to work with the science. So we'll stick with the science.
Yeah, and I guess, Julie, I mean, I feel the same way, which is, I mean, right now, the big models, which we suspect that they have not all the mechanisms that are important, but they are projecting, you know, that plants will offset a bunch of this release. And so we can't turn around and say these models are incorrect. I think we can look at the wide range of knowledge systems, including the big models, but not just the big models, to say like, hey, we haven't gotten rid of these worst case scenarios. But you know, when people are going to be talking about NDCs, they're talking about real money. And so if you have 10 billions of tons of extra carbon, of net carbon coming out by the end of the century, that's very different than if you have hundreds. And someone has to pay for it. And so that's why, you know, as scientists, we have to kind of give the range. But I think, again, the risk framing, which is we still might want to plan for avoiding a worst case scenario, is a helpful framework for people thinking about policy. I don't know if any other people want to chime in on that point.
Ted, it's Vladimir. So I think that another problem is that these models which are used to estimate degradation of permafrost or amount of permafrost that will be degrading, well, they're not really great models in terms of permafrost. And when you talk about difference between 2-degree warming and 4-degree warming, that's you know, you can use these models to show the really difference. But when you talk about 1.5 degree and 2-degree warming, that's already coming to the point that those models really cannot, well, the uncertainty in the models will not, you know, be good. Uncertainty is so big that you will not be confident in this difference. So if you really want to go to that details, so there should be some much more work should be done to do high resolution permafrost modeling, and that it will be more confidence, and then you can talk about the difference between 1.2 degrees and 2 degrees. Otherwise, it will be all, see what I mean? So the models are with uncertainty. You cannot resolve this small difference in forcing.
Yeah, and I think that's a good point. And I mean, others could speak more to why 1.5 was brought up almost, you know, I don't think that arose out of the science community as much out of the policy and human dimension of why there was a 1.5 degree report overall. I mean, you're probably correct about, you know, our ability to differentiate 1.5 and 2 is quite limited. I think from first principles and from physics, I guess, we know that, you know, as temperatures rise, you know, rates will increase. Or rates of change will increase. We don't know if that's linear or has a curve to it, but I think we can safely say, you know, if we're saving permafrost moving from RCP 8.5 to RBC 2.6, we would be likely to save more permafrost, you know, at 1.5 degree warming. Whether we can document that all and observe it, you're probably right, Vladimir, but we have to also think about, you know, who we're communicating with at this level.
Thank you, Ted. I think we are at the end of our webinar. I want to say thank you again for presenting and for all of your participation. Maybe Meredith, do you want to quickly announce our next webinar, and then we'll probably close this call?
Sure. Yeah, I will let Miriam announce the next webinar, but I do want to note that there is a question from Twyla Moon in the chat, just asking if there was discussion about making easily digestible figures or communication tools.
Yeah, let me do this, which is I will look up the question about standalone figures from Peter and Twyla and give you a sense, because there are some press release materials, and I have to figure out how those trickled back from the summary for policymakers, which had its own figures, to the chapters themselves. I would also say, because we're, you know, maybe I talked too much and we're wrapping this call up, that if anyone wants to engage with me further over email or points you want to know about, I would love to think about, again, how we as a community can move this information out to more people. Thanks.
Great. And Miriam, if you want to give the information on the next call, which I believe will be on November 12th at 10 Alaska to Eastern.
Yes, so the next permafrost collaboration team meeting will be on subsea permafrost. It'll be a report back on an expert assessment survey that was largely carried out since the last PCN meeting at last AGU. And Sarah Sayedi will be reporting on the results from that. So tune in.
Great, thank you. I also wanted to say we'll provide all the material from this call plus a recording of this call on the IARPIC website. So there will be some of that information, and we can probably add the links to the IPCC report, etc. as well.
Yep.
Okay, well, thank you all for calling in.
Thanks, everyone.
Great, thanks so much.
Thank you.